Welcome. It's great to see you. This meeting is, as you might have just seen in notification, being live streamed to YouTube as well. We are setting that up. Thank you for your patience. As one, I mute my voice so I don't hear myself talking. But two, as we wait just a few minutes for others who are going to join us. In the meantime, one of the things we love to do is welcome those that we recognize. Rich, of course, you're at the bottom of the list, which is where my cursor happens to be, but thank you for being here. For those of you who don't know, Rich looks after learning at ClickHouse and teaches so many of our users all the things. Alexei Lizunov, Alon Tal, and Selma, welcome. Dennis, pleasure to see you. Eugene, Larry, good as always. Alexei, for you. Ramazan, mate, it is a delight to see you here. While we wait to get started, my name is Tyler, and I'm actually based in Amsterdam. Alexei is as well. I see him periodically, although fairly infrequently. The beautiful part about distributed systems and the distributed teams building them is that users and team members can be around the world. I'm always wildly intrigued to see where people come from. It's also an excuse for me to say that Q&A is open and chat is open. So please feel free, whether you're on YouTube or on the Zoom that we have running, to chat and let us know where you're joining from today.
Yeah, I hope you still remember me. I am Alexei, by the way. Nice to see so many people already joined. So many already familiar people. Hi, Ricky. Nice to see you. Hi, Ramazan. Hi, Larry. Stefan, nice to see you in the list. We will start maybe in 3 minutes.
Perfect, and I'm just tweeting that the YouTube stream is live for those who are joining from there. So if you're on YouTube, if you're one of the people watching there, thank you. Folk from Brazil, from South Dakota, from New Orleans, Turkey. Yeah, it's awesome to see people coming from sort of all over the place. It's spring. Or at least ostensibly so. In Amsterdam, it's gray again and has been windy all day long. So I'm not quite sure that I believe that it is spring, but it's meant to be.
What is the most unusual place for people, for our attendees to join? Anyone from New Zealand? Anyone from French, Polynesia?
I suspect that if you're joining from New Zealand, you're probably sleeping and catching this on the recording, which I mean, I know it's a ClickHouse release, but I also know that it's like 3 o'clock in the morning in Australia, which I don't remember how Australian and New Zealand time zones overlap, but it doesn't mean that someone's not up.
3 o'clock in the morning is not a problem for ClickHouse developers and for ClickHouse users.
True enough. I know that because I speak with you at that time of day. Awesome, cool. Well, I think we'll go ahead, Alexei, and we'll kick off. I've seen the content. I know that we have quite a bit to cover. Let me start first by welcoming you. I don't know if this is a release webinar, if it is our monthly community call, if it's the 23.3 release announcement. I'm not sure what this thing is, but this is a thing that I delight in and look forward to every month. There are vanishingly few projects, be they companies or otherwise, where you can hear from the founder about what is happening and about what is coming. And even as a member of the ClickHouse team, I always look forward to our release calls. And more importantly, I look forward to the conversation with those of you who are joining live, be it on Zoom or on YouTube, high YouTube delay, as well as for those of you who send us questions afterwards. So with that, I'm going to hand it off to Alexei. Alexei, it's 23.3 time.
Yeah, thank you. Let me share my presentation. So today I will tell you about ClickHouse Release 23.3. It is about ClickHouse Spring Release. I will try to spend most of the time describing the new features, and we will have just a few minutes for questions and answers. So what it is? This is a long-term supported version. It will be supported for at least 1 year. It has 22 new features, 14 performance optimizations, and even more bug fixes. Let me describe the new features, then performance optimizations, and then maybe you will have a chance to ask a question about bug fixes. So what do we have? UNDROP table. What it is? Did you know that whenever you are dropping a table in ClickHouse, it is actually not dropped, but it is not a fake. There is a reason for that. The reason is that ClickHouse is using lock-free multi-version concurrency control for atomic DDL operations. But in simpler terms, you can run a query from your table. You can drop this table at the moment when a query is still running. You can create another table with the same name. You can run another query and have multiple queries from old table and from new table at the same moment in time. And the dropped table will be collected in background when every query will finish, but not earlier than after 8 minutes. So when you drop a table by mistake, you still have 8 minutes to undrop it. By the way, why 8 minutes? Maybe I wanted to describe the exact reasoning for this magic number. I like the number 8. It looks good. It is lucky, but I will not describe it now. There is a reason for that. And if you know the reason, please write in chat. If your answer will appear to be correct, you will get a gift from me. Okay, so in previous versions, if you dropped a table by accident, the only way was to immediately stop the server and call a support, and the support will help. In newer versions, it is self-service. There is specific undrop table query. You just run it, and the table is restored, and you can take something to clean your to clean sweat from your face. What else? We also have a system table named System Dropped Tables. It will display all the recently dropped tables that are still available for undropping. Another feature, even more interesting, introspection for server settings. We have many different kinds of settings in ClickHouse. User profile and query level settings. They are visible in the system settings table, and it is easy to change user profile settings, query level settings simply by set query there are table level settings available inside system.merge3 settings. And now there is also introspection for server level settings. Server level settings are global. You cannot change them without editing the config file, so they are significantly more important. And maybe you want to introspect. What are the current values? What are the default values? What settings are available? Let's take a look. I have a demo for this. Let me switch and I will run a server. Here is my server. And I will copy paste some queries to the terminal as usual. So let's take a look. First, I will check what is inside this table, system.server settings. It works. There are 52 settings. By the way, for security reasons, it does not include every setting. It includes only simple settings on the first level of configuration file. So no passwords, no usernames, only selected settings. The table contains documentation for all of them. Let me show you how you can make this documentation easily turn it to HTML page. I will make this query that will format every setting as markdown. Here it is, my markdown. And the easiest way to display it is to simply copy paste and use my favorite service, parseDateTime. After I copy paste it, I will simply add markdown extension, and here it is, the documentation for my settings. Pretty nice. But there is a simpler way. Instead of formatting markdown manually, I can simply write something like this. Select star from system.server settings, format markdown. There is a format in ClickHouse specifically for formatting markdown. And it will look like this. Let me again copy paste it to my favorite service, parseDateTime. And it looks like a table formatted in markdown. So nothing special, pretty nice feature. Let's look what else do we have. Nested dynamic disks. I already told you about dynamic disks on my previous webinar. But now these dynamic disks can be constructed on top of other dynamic disks with arbitrary level of nesting. What is it for? It is for tables that you can host anywhere. You can take a table and export it to any HTTP server. In this example, I have a table that I have hosted on this web server, row.githubusercontent.com. I simply hosted my table on GitHub as a set of files. And here is the address of my exported table. But I'm doing something pretty interesting in this example. So here is one disk of type web on top of this endpoint in orange. And I am creating another disk on top of this disk. And another disk is of type cache. And the cache will be located in my home directory, up to 10 gigabytes of size. Maybe it is difficult to explain, difficult to imagine. Instead, I will just copy paste all this query, and I will let me see what will happen. Maybe it will work, maybe it will not work. It depends on GitHub. Sometimes GitHub works, sometimes it does not. Okay, let me switch to some database and copy paste this query. What will happen? It works, surprisingly. Let me try to select something from this table. So again, I don't have this table on my server. My server is my PC. On this machine, I am querying this table located on GitHub. I just attached the remote table. Let me check if anything will work with querying this table. Let me calculate the average price for every year, the average home price of homes sold in the United Kingdom. Wow, this query works. And it is fast. If I will run it again, will it be faster? I don't know. No, it is the same speed. Actually, the cache was already pre-calculated. Let me check. It should be located here. Here is my cache. Some cryptic files of strange size. What if I will drop this cache? I hope I will not do any mistakes while writing rm-rf, because otherwise we will have to stop our webinar. I hope everything will be all right. Let's double check this comment. Okay, if I will run this query again, it should, wow, it is fast. I cannot make this query slower. I don't know why, but it is always fast. It doesn't matter if I have cache or if I don't. ClickHouse is always fast. Okay, what else? Something for MySQL compatibility. What about MySQL compatibility in ClickHouse? First, I would like to say that ClickHouse is not MySQL. We want to be above that. ClickHouse is not Postgres. We also want to be above all of these databases. ClickHouse is better. But if you really want, ClickHouse can pretend to be MySQL for you. It has support for MySQL wire protocol. And you can connect to ClickHouse with MySQL like this. And this is about the wire protocol. If you will do some queries, you will have to write it in ClickHouse SQL dialect. And it is different from MySQL dialect. It is also better. And the set of functions is also different. Let me cross-check just in case. I will connect to ClickHouse pretending that it is MySQL. Here it is. Oracle is a registered trademark of Oracle Corporation. Doesn't matter. I don't care. Let me check what it is. Version 23.3. But I can also do something like this. It is ugly, but it works. And here ClickHouse will answer that it is MySQL of version 5.7. How to improve MySQL compatibility? Actually, you can use MySQL protocol to connect some already existing tools. And they will expect that they are talking to MySQL, and they will ask ClickHouse strange questions, strange queries with some unusual functions. And we can simply add compatibility for these functions, some aliases, some names, some operators. So now we have this. In instr, it's strange name to check if a string is inside substring. So there is a leak inside ClickHouse. Regex to check if something matches a regular expression, and store_to_date. It is compatible with MySQL, but obviously ugly. If you want to write it in a ClickHouse way, better to use ClickHouse functions. Position, case, insensitive. Look at this function, how much it is better than instr. Tyler, could you calculate how much times it is better? Much better. If you want to match a regular expression against a string, just use the match function. If you want to parse datetime, just write parseDateTime. This is better. By the way, what about parseDateTime? We have a new set of functions. We already have functions like toDateTime to parse the date time in the ISO syntax. We have parseDateTime best effort to parse any kind of date time, but now we also have a function named parseDateTime to parse date time in a specified format. And we also have a function parseDateTime in JODA syntax. What is JODA? Maybe you want me to tell you, but no, you tell me what is JODA. If you are a Java developer, you know what is JODA, and you know every word starting from J. JODA is something around that. So it's basically a different syntax for formatting dates and date times like this. Okay, some improvements for Parquet, org, and arrow formats. Now we can control compression method. For Parquet or ORC or arrow, and we switched it to LZ4 by default. In previous versions, it was snappy, but LZ4 is better and faster, so we switched it. You can also control the format version for Parquet. For example, you can write it something like set output format Parquet version equals to 1.0. If you have to deal with some old application to consume this Parquet format. But ClickHouse can work with the latest version and any version, because ClickHouse is good. This feature is boring, but I still have to tell you about this boring security feature about authentication in the native protocol with SSL certificates. It is easy. Just create X509 client certificate and specify it in a configuration file for ClickHouse client. You can write a configuration file in config.xml or config.yaml. Usually I use config.xml, but XML does not fit on this slide, so I written it in YAML. What else? What about lightweight deletes? And I am pleased to announce that lightweight deletes are production ready in version 23.3. And this version is long-term support version. So starting from this point of time, by default, the delete from queries are available. And unlike MySQL, unlike Postgres, you cannot write simply delete from table. You have to write where. Because how many times you forgot to write where? Okay, what about performance optimizations? We have quite a few. First is about compression of marks in memory. I hope you still remember what marks are. It is just part of the index that has to be cached in memory, but does not have to be completely in memory. So there is a mark cache limited by size, by default just 5 GB. And this mark cache should contain the frequently used parts of these table marks. What if you have tables like 100 terabytes on a single server, 500 terabytes on a single server? Actually, there are no limits. I don't know how big tables do you have. Maybe you can write somewhere on YouTube, in Zoom chat. And if your tables will be the largest, and if you will not be cheating, maybe we will send you a gift. But you have to describe what type of data do you have in your tables. Okay, starting from version 23.3, marks are compressed and take about 3 to 6 times less space in memory. And surprisingly, we don't have any setting for this feature. It is enabled by default. You cannot even disable it because it works perfectly. Let me check how perfectly it works. So let me find some big table. And let me start the previous version of my server first. I downloaded the previous version, 23.2, and I will run it simply as follows. It does not run because I have created a table with dynamic nested disks not supported in the previous version. I have to drop this table first. By the way, do you want to test the UNDROP table feature? No, I will not test it. I want to drop table. I dropped it. Okay, let's start the previous version. Okay, looks like it started, and ClickHouse client shows me that yes, this is an older ClickHouse server that I should upgrade immediately. Okay, let's check what is with Mark cache. I'm selecting from the system asynchronous metrics table. It allows introspecting some metrics like mark cache bytes. And currently the mark cache is empty. Let me do some query like this. I will select from the hits table, and it should load the marks for every column. Here it is. And now the mark cache is 20 megabytes. Not much. Let me check what the difference will be if I will use the new version. Okay, it is started. The mark cache is empty at startup. I will run the same query. It is as fast as before, 0.078, and it was 0.080. So there is no negative implications on query performance. And now the mark cache is just 5 megabytes, 4 times less. Perfect. Okay, this is way more interesting. Optimizations for backups. How many times you run backup table for a table of 100 terabytes in size? It was almost not possible before, but now a backup for this table finishes in just 1 hour. Incremental backups finishing in about 20 minutes. It still takes 20 minutes to go through a million of files and to compare checksums. So we have optimized it. We optimized it using server-side copies for S3 if you do backup from S3 to S3. We use dedicated thread pool, increasing parallelism, faster writing of metadata. We retry keeper operations, and it looks like this. 100 terabyte the service, and backup took slightly less than 20 minutes. 19 minutes, 51 seconds. And from this screenshot, you might think that maybe it is applicable for ClickHouse Cloud. And I will say, yes, it is applicable for ClickHouse Cloud, but not only. If you manage it to self-manage ClickHouse Cloud with S3 storage, and you do a full backup to another S3 bucket or to the same S3 bucket, it will also use these optimizations. All these optimizations are applicable for the cloud and any self-managed setups. But ClickHouse Cloud is obviously more convenient. Another optimization, parallel replicas. So what are parallel replicas? Imagine that you have 100 of servers, and instead of creating shards, you are thinking something like, okay, I will create 100 replicas. I don't care about shards. And actually, it can be practical. It can be practical if you run ClickHouse on top of shared object storage, like in ClickHouse Cloud. You can do it yourself if you really want. So let me try to run a query from a table that will read 1 terabyte of data. And without parallel replicas, it took about 8 minutes, 458 seconds. Actually, it is fast, 2.55 gigabytes per second. But I don't want to wait 458 seconds. It is just too long. So why don't I use 10 parallel replicas? And to enable this feature, it is still experimental. So I have to enable this experimental flag and set max parallel replicas to 10. And now it takes just 40 seconds. And the speed improves to 29 gigabytes per second. One strange thing is that query scaled super linearly. It was 458, and now it is 40. Why? How ClickHouse can scale not just linearly, but super linearly? You can say that ClickHouse is ClickHouse. We should always expect something even better than usual. Maybe you have any ideas, and if you do, please write in chat. We have a lot of gifts, so don't hesitate. Write, what do you think? Okay, but 10 replicas are not enough for me. I tried to increase the cluster size to 100 of parallel replicas. And if I use shared storage, it is easy. It is easy because 1 minute I have 10 replicas, and just after a few seconds, my cluster scaled out to 100 of replicas. And now query took 8 seconds. I am slightly dissatisfied with this result because it should take 4 seconds or even 3 seconds, but 8 seconds is less than linear scalability. But the fact is, the query processing speed is 134 gigabytes per second, and this is nice. You can do even more with parallel replicas. Since version 23.3, we have a feature named parallel replicas with dynamic shards. So you should not mix up and be confused with shards and replicas. They are different, and typically you have shards and replicas. But this feature can make you slightly confused because now you can have a cluster with replicas and make every replica to represent a shard for distributed query. And the sharding key can be specified dynamically, like follows. Parallel replicas custom key equals to whatever, a column, expression, and in this example, we will dynamically represent every replica as a shard by user ID. And you can select between 2 filter types for sharding. The default filter type will make every replica read a subset of data by a remainder of division of the key to the number of available replicas. Say you have max parallel replicas equal to 100 and 99 replicas are alive, 1 replica is unavailable. It will go to 99 replicas and request reading the data when the user ID modulo 99 equals to the replica number. You can set the filter type to range. And it is especially useful if your tables are sorted according to this custom key, because it will save the amount of I/O. Replicas will physically read less amount of data. And what is it for? If you do a large query with group by or a large query with join, you can simply make dynamic sharding by group by key or by join key. And the data will be joined or aggregated locally. Yeah, pretty advanced feature. Do you get it? Interesting. Tyler, did you get that?
I was live tweeting at the time. So honestly, no. I'm going to have to spend some time playing with it and see what I can figure out from it.
Okay, no problem. But you know what? You don't have to care about this feature, but if you will think how I can make my queries 10 times faster, this feature will help. Okay, what about something unusual? And one unusual feature is to get incomplete query result. Why do you need incomplete query result? Let me show you something. By default, you will get everything properly. But if you really want, you can enable this setting. Partial result on first cancel equals to 1. Let me try to experiment on my server. And I will do something like this. Select star from hits, order by, limit 1. It will select all the fields, all the columns from the table. The table contains 100 million records, and this query will have to scan all these records. It will have to scan maybe 100 gigabytes. So probably this query is not going to be fast. Let me check. Actually, it is not slow. 13 gigabytes per second, 5.99 seconds. Is it fast? Yes, it is fast. But I don't want to wait 5.99 seconds. I don't want to wait even 1 second. What if I will start this query and cancel it? Oh. It will show nothing, because I canceled this query. Why it should show anything? But now we have an option for that. Partial result on first cancel. Oops, there is no such option. Because sometimes we have to apply last minute changes for the release. And I have renamed this setting. It was named differently. So the actual name in the release will be partial result on first cancel. But in the master version pre-release, it was named how it was named.
Stop reading on first cancel.
Yeah, let me check this setting on the master version. And I will run this query. And by the way, you can think that I have ADHD or something like this. I don't want to wait even 5 seconds. I'm distracted all the time. So let me start and cancel this query. And it gives me some result, some partial result. And it can be especially useful if I do some aggregation. Let me run some aggregate query like this. Top search phrases and the number of unique page titles. 1 second. And here is the reference result, the complete result. I don't want to waste 1 second. I want to get the result faster. Now I also have the result in just 0.7 seconds. And the numbers are different. So it was like 6 million for empty search phrase. Now it is just 5 million. But you can see that the order of search phrases is about the same. About the same, but slightly different. So you can get approximate result faster. What else? Temporary tables now can be created with arbitrary table engines. In previous versions, temporary tables were always in memory. Now you can create merge tree temporary tables. They can have order by key, indexes, projections, constraints. What else? Codex, anything. And be temporary. Why do you need such feature? What for? I will give you 5 seconds to answer these questions. If you will answer correctly, I will say that congratulations. Now go and install the latest version. Tyler, do you have some answers?
Sorry, I was muted. We do not yet. YouTube is still catching up for preparing temporary data sets for join, or because sometimes memory just isn't enough.
Mm-hmm. Okay, not bad, but why don't you use normal tables for this? Any more answers?
No more that are coming in. For usage of low memory is another one that came in. So it feels like people are sort of orienting towards the memory constraint. Mm-hmm. Multi-stage ETL comes in from, or the data is just temporary. Like the data is actually just temporary. I'm not sure if you believe in that concept, Alexei, or not, that data is temporal. Store all the data and get answers from it fast.
Who said multi-stage ETL?
Ricky said multi-stage ETL. There's another one that came in that I think is actually quite interesting, which is using it for DBT to insert it into temp and then attach partitions from it.
Wow, this is definitely above what I expected. So who said this?
That's from Constantine. Constantine, sorry.
Perfect. So Constantine, we will send you a gift. Okay, what about integrations? For Superset, now when you install Superset, it has ClickHouse support out of the box. You don't have to install and build any plugins. Everything works with ClickHouse. ClickHouse is the first-class citizen in Superset. What about Grafana? In Grafana, we have support for traces and spans visualization. If you store open telemetry data or whatever telemetry data, open telemetry, closed telemetry, does not matter. But you definitely want to store telemetry in ClickHouse because ClickHouse is the best, absolutely the best choice. And Grafana will render these traces for you. And also we have updates for Python, Node.js, Go, and Java drivers. So in Grafana, traces look like this. And not only Grafana, you can use Zipkin, Jaeger, and if you want something even more powerful, you can use a tool from my a friend named Querying or Querying. It is a polyglot monitoring and observability. So take a look, maybe it will be useful for your use cases. What else? And just to remind you, there is ClickHouse Cloud. And if you sign up, you will get 300 free credits for 30-day trial, up to 10 terabytes of data. ClickHouse Cloud is probably the best way to start using ClickHouse. And thank you. We have about 10 minutes for questions.
Awesome. And we have quite a few that have come in. And again, for those who are following along on any of the platforms where this is live, please feel free to ask questions. We're kind of keeping track of them here in the background. So first of all, Alexei, from Dale and I, we saw JodaTime. Can I say that you have finally been inspired by Java?
Yeah, but actually not me. I did not submit this feature, and I did not review it, and I did not merge it. Maybe if I would be reviewing it, I would say Java. No.
Awesome. There's a number of other actual questions versus me just giving you grief. One of the questions is, can we set up logical replication to ClickHouse tables in the future from Postgres?
Interesting because we have experimental support for physical, if I recall correctly, replication from Postgres, but it is not entirely physical. The queries that are changing, the tables are logically replicated, and probably you cannot change the tables at all. You only replicate the data. But we do. It is named materialized Postgres. And for logical replication, you know, the answer is maybe. Maybe we will consider it. But it is always tricky. Logical replication requires the database to follow the logic. And if it does not, the replication will break. If it does not interpret correctly all the details of the queries, it has to replay the log 100% identically. So it can be tricky.
Gotcha. Related to, well, not related to that, but it's sort of moving on towards the compression marks. Usually take before compression as a percentage of data size, assuming that everything's loaded. Like basically, how much are we actually saving, do you think?
So, did you know that the marks on disk can also be compressed? And if the marks on disk are compressed, they will be loaded in memory and compressed by a different algorithm that is optimized for memory. But the algorithm is different. So the compression ratio can also be different. Typically, it is like 3 to 6 times. And how much you would save? So I experimented on a table with Tyler. Guess how many records?
I'm not sure.
300 billion.
Okay, yeah.
And the marks took about 10 gigabytes. After compressed marks were enabled, the size was around 1 or 2 gigabytes. So pretty big saving. And it makes sense for heavy queries to always hit the mark cache, because if they don't hit the cache, marks will be constantly loaded from disk, discarded, loaded again, discarded, and so on. You don't
Right,
want.
right. Well, and the reason I asked that is that there was another question, was whether marks and IDX were compressed on disk, which I think, you know, the interplay between those two approaches to compression, I think, is important. One other question on that front before we switch to sort of another topic is, if marks are compressed in memory, then how does ClickHouse do operations like searching on that compressed data?
Oh, a very good question. So we are using a compressed data structure that allows random access. So the marks are still random accessed, but we just trying to find out what bits are unneeded. And we calculate some base value, like position of reference, and calculate the difference from this reference value. And the difference will be small, and it will take less number of bits, and we will pack these bits together.
Gotcha. So shifting topic then for a second, parallel replicas. There was a bit of chat about that, quite a bit of interest, of course. When are they no longer going to be experimental?
No, it depends. We're still optimizing this feature, and you saw the numbers, like 40 seconds for 10 replicas, 8 seconds for 100 replicas. We still have to optimize 2 times more.
Gotcha. So it'll depend on the sort of optimization and progress that we as a team at ClickHouse, as well as we as a broader community, for those who are contributing, are able to make in terms of optimizing parallel replicas. Is that true?
Yeah, that's true. And testing is also valuable because we have to test it in many different scenarios. One scenario is like replicated tables over shared storage with another experimental feature, zero copy replication. Another scenario is statically attached tables from disk web. And the placement of these tables on replicas can also be different. One example is normal replicated merge tree tables. Another example is multi-region cluster. Multi-region cluster can be located in different countries in Europe, or it can be spread across Europe, the United States, and Japan. And somehow this cluster works. It is difficult to imagine, but you just took the globe and put 3 random points on different sides of the globe, and ClickHouse works.
Gotcha. So we're getting close to time, but there's a couple more questions. So if you don't mind, Alexa, I'll ask you another one or two. Are there any plans to have materialized views that are built of joins to trigger when any update updates?
Sorry, you was interrupted, but looks like I get this question. It is not so easy. Materialized views are simple, and you know, many features in ClickHouse many features are also elegant and simple, and materialized view is also elegant. And it means you cannot update join tables with materialized views, and it is actually not bad. It makes the system easily understandable. You can easily understand how materialized views work. They are simply inserting the new data on insert and nothing else.
Gotcha. All right. Well, we're out of time. There's a couple other questions. A number of them actually reference GitHub issues related to replicated merge tree restore on backup, or some concerns about lightweight delete implementation, or even an issue that was raised on why a particular feature was of import for someone. In general, I'm going to say that as a community, because we as the community work on ClickHouse/ClickHouse and GitHub, not just the ClickHouse team. When you have a question about an issue in specific, be it that comes out of this session or be it more broadly, please feel free to raise it in that issue, because it's always great to explore replicated merge tree restoration after backup in context of the issue, be it something that was closed or something that remains open. So always feel free to engage with us in GitHub, or go to clickhouse.com/Slack, which will redirect you to the Slack invite. We are always there. Thank you all so very much for joining us today. For the first time since we've done this, there were actually more humans on YouTube than were on Zoom, which is kind of great. I kind of like that. We're going to post the recording of this live. It'll take an hour or two to get processed on the YouTube. And then we'll start sharing information about it in Slack, on Twitter, on LinkedIn over the next week or so. My encouragement for you is when you can, download, start playing, and let us know what you want and help us make the future of ClickHouse. Alexei, anything to add before we end it for today?
Yeah, thank you. See you next time in April.
Cheers. Be well, all.